Yeah, hi everyone. Thank you for joining this webinar. Yeah, good morning, good afternoon, good evening from wherever part you are joining this webinar. Once again, I thank you everyone for attending this. My name is Sanjeev and I am joined by my colleagues Steve Vasilko, Jack Link and Vijay Kulkarni. In today's webinar, we'll be discussing about optical repeat tag repeaters and multiport T1 repeaters. I think most of you know what GL communication is, but just in case if you are new to this, I just want to give a brief introduction about our company. We are located in Gaithersburg, Maryland, USA, and we have been founded in 1986. We are a company into both telecommunication product test and measurement products, and also we do telecommunication consulting services. Under the product division, we have covered. We have got many telecom test and measurement equipments which are spread across all the telecom networks, namely the going from the latest technologies like 2G, 3G, 4G, including 5G, and we also have the many tools in the Ethernet IP networks, also in the wireless networks. Majorly, our core expertise lies in the protocol analysis and emulation, which are one of the key products what we sell. Apart from this, almost all our products are PC based and they are very user friendly to use. And we have been into this business since from quite 30 plus years. So we have covered almost all the uh, networks and almost all the uh, markets where telecommunication test equipments are required. With this small note, I'll ask my colleagues to continue the session.
Okay, thank you, Sanjeev. So the topic of the webinar today is optical tap repeaters and multiport T1E repeaters. As the name implies, these units are useful in the lab for testing purposes, and they can be used with our test equipment for T1E1, SONET, SDH, Ethernet technologies. And the way they work, the top two, these two units can operate at optical 100 megabits to 2.5 gigabits, and another version can operate up to 10 gigabits, all the way down to 100 megabits. These are our optical Ethernet, SONET, SDH type of repeaters. They come in very handy, especially these days when all of the technology is Ethernet technology is ramping up to gigabit range. Now, old legacy technologies, we have single T1E1 multiport repeaters that we have been marketing and selling for throughout the history of our company, as well as these dual T1E1 multiport repeaters. So we'll be talking about all of these, their configurations, what they're useful for, when to use them in the remainder of this webinar. Okay, so there are basically two applications for using these repeaters, and they are loading. When you want to load a network or a piece of equipment with a lot of circuits, a lot of interfaces. So it's very useful for high density traffic testing to test the capacity or the performance or the fault tolerance of a piece of equipment or the network when it is loaded with a lot of traffic, a lot of interfaces. And so these repeaters, although they duplicate what is on one circuit, but that sometimes is not as important as actually the amount of traffic that you are trying to impinge on the device or the network. So loading, this is a very useful, these repeaters are very useful in loading. And the other application is for monitoring. When you're monitoring, for example, a 10 gigabit link or many gigabit links, you want to be able to apply monitoring and diagnostic equipment in parallel against those circuits, because it may be that the analysis requires a lot of horsepower, especially if you're doing things like deep packet inspection or doing a lot of call records and analysis. When you're analyzing thousands and thousands of circuits simultaneously, multiplying the circuits and dividing and conquering the monitoring is a good thing, is a more powerful way of doing it. So these are the two general applications for these these optical tap repeaters and P1 multiport repeaters. So here's a little bit more about what loading actually means. If you have an emulation system, and we'll show you some, we have in our inventory, in our product line, we have emulation systems for practically every protocol, starting from analog protocols like CAS, MFCR2, all the way to ISDN, SS7, Ethernet protocols, wireless protocols. So we have emulation systems for all of those, SIGTRAN, SS7, the protocols that you encounter in the wireless domain as well. Normally, the emulation systems are very complicated and they're expensive. So you can't necessarily afford to buy an emulation system that can generate, let's say, 20,000 unique calls, or it would be very expensive, let's put it that way. So you could buy one that generates thousands of calls, and that's the emulation system here. And then you can apply that to a repeater system, the kind that we're talking about here, and that would multiply that one single interface to multiple interfaces, thereby testing this high-capacity switch, gateway, or transmission equipment, or the simulated real network. So this is a typical application. Buy a less expensive emulation system, multiply the circuits, and load a real network or a large piece of equipment, or a gateway or high-capacity equipment, and see if it performs adequately for all of the calls that you're generating. Okay. The next, I also mentioned monitoring. So let's assume you wanted to monitor the traffic between point system A and system B. You could route that traffic through a repeater subsystem and distribute the load to multiple monitoring systems. This one might be getting all the call records and performance analysis for calls, whereas this one might be handling maybe the some n number of circuits. For example, if this was 100,000 circuits that were going from A to B, then this could be load balancing. Each one could be supporting 10,000 circuits. So a typical application. Another application is when the distance between the monitoring system and the traffic to be monitored is a great length, then the repeater system provides distance, solves the distance problem, so that the signal is not attenuated too much until it reaches the actual monitoring system. Okay. All right. So now, how does the actual monitoring or tapping principle work? I'm going to show you first. Let's talk about how it's done the old way, and then we'll discuss how these repeaters kind of give you an advantage over the old way. Usually, if you're monitoring a signal, whether it's optical or resistive, like T1E1 that is riding on copper, you have to take the signal, whether it's optical or electrical, and you have to split it. You can usually split it with a resistor. If you put a resistor at this point, you can split that signal. For example, like if you use 470 ohm resistors, you can extract a small amount of voltage current from that signal. So the majority of the signal goes, 90% of the signal goes, let's say, to the intended target, and the 10% goes to the monitoring solution. So in this way, you are actually altering the signal that is being monitored, because the original signal coming in on A going to B is actually 90%, or in other ways distorted from the original signal. Now that distortion might be meaningful or may not be meaningful. And the monitor signal also may have some distortion on it. So usually that is not a problem if the distance between the monitoring equipment and the actual location is close by. So that distortion is very small and it's meaningless. But if it's a long distance, or you're very careful about the quality or the integrity of the signal that you are monitoring here. You don't want to introduce any errors or distortion or jitter or anything of that nature. Then you may not want to use this type of signal. Okay, so here is a typical optical tap, where the original signals go through the optical tap at, let's just say, 90%, like I mentioned in the previous slide, or some other factor, and the actual attenuated signal comes out of these two ports and is fed to copy A, copy B. So this is a typical optical tap, and as I said earlier, it does distort, or it does modify the signal somewhat. The input signal is not identical to the output. The output, rather, is not identical to the input. So there could be, for example, if it was a 90-10 tap, it's a 20 dB loss. The tapped signal is 20 dB attenuated, and the through signal is 1 dB attenuated. So that might be acceptable. A 70-30 tap might have a different ratio. But the important point is they're not identical signals as the inputs. And many times, if you're very interested in the integrity and or the equipment is not close enough, this could be a factor. Okay. So what we have here in this talk, we're going to talk about repeating rather than tapping the signal either resistively or optically. We're going to be talking about repeating the signal. So the actual output signal is equal in almost all respects to the input signal. It's regenerated. The bits are detected and regenerated. Zach, did you want to talk about this one particularly, since you have been doing all of the testing on our repeaters? Talk a little bit about this slide.
Right, so here you can see the 6-port optical tap repeater. It can handle data rates from 100 megabits per second to 2.5 gigabits per second. And it has 2 modes, which we can talk about in the next slide. Mode 1 is a 1x5. And you can see the top 2 ports are crossed, so it provides a through mode, so you can have uninterrupted east to west traffic and vice versa. And the bottom 4 ports are the repeated signal from port 1. So essentially you have 1 input on the top port and then 5 repeated signals below.
And the mode is controlled by this mode switch, and we also have a USB connection that allows us to interrogate these SFPs, since in almost all of these configurations for the optical repeaters, these are all SFPs. So do you want to discuss the SFPs, Zach?
So we provide either single mode or multi-mode SFPs that will cover up to 2.5 gig data rates, but they are multi-rate, so they can do anything in between 1 gig to 2.5 gig. And then we also supply 100 megabit SFPs as well.
Right, and they are either single mode or multi-mode. So if you order this equipment with single mode, you get a multi-rate single mode SFP assortment, so you can handle all the rates. And if you elect for multi-mode, you can do all the multi-mode rates. So that's a very convenient way of doing that. We have another mode, or here's another depiction of the same mode 1 repetition. Zach?
Right, so here's what the actual box would look like. You have input A on that rightmost port repeated to the 4 ports on the left, and then you have the A and B cross traffic. And if B were to be in A's position, it would be B that was repeated.
Right. And the white is showing you mode 1 here, right?
Right.
So this was we worked on this graphic quite a bit to make sure that customers would understand that this receive signal coming in to this particular SFP port is white. That's mode 1. So you can follow the white to where it appears, and you can follow the blue, which is mode 2, which we'll talk about in a second. So here, A is being repeated 4 times here, as well as repeated here, so that you actually get 5 repetitions of A. But if you wanted to send the signal through, you might be using that for both A and B systems. Those are the 2 systems that are talking to each other. Okay. Here's the other mode, Zach.
Okay, so mode 2, when you flip the switch up, you get the same 2 ports crossed, so you still have that through mode, except port 1 now repeats 3 times to port 2, 3, and 4, and then you have port 2 signals repeated to ports 1, 5, and 6. So you end up with 3 outputs of 2 different signals.
Right, so here's RX2, RX2, and RX2. Zach, can you see my cursor?
Yep.
Okay, so the RX1 is being repeated here, as well as these 2 ports, and RX2 is being repeated that way. RX2 is equal to TX2, as well as at these lower 2 ports. And again, the USB is used to interrogate these SFPs and provide you all of the data from the SFP. For example, if you connected the wrong SFP into the wrong port, for example, the USB software that comes with, if you connected it to a PC, it would automatically read the SFP data and tell you that you've got some wrong SFPs connected. So it's a very useful thing to you can also use that software to monitor the signals and signal levels and so on. Okay. Here is the faceplate. Zach?
Right, so this is just another display. You have the A input on port 1 repeating back out ports 3 and 4, as well as port 2, and then you have the input B repeated on ports 5 and 6 on the left there. And then you still have that through mode. And that, if you follow the blue line, that's what that tells you on the overlay.
Right. So in this, you can see that the A is repeated as well as the B is repeated. In mode 1, all of these were A, and none of them were B. And so that's the difference between mode 1 and mode 2. It just gives you a lot more flexibility in operating these repeaters, optical repeaters. Okay, here's the rack configuration, Zach.
Right, so we can put 3 units in a 1U rack, and this could be useful for cascading, or if you just want to condense all your units. We can talk about cascading on the next slide.
Mm-hmm.
So in mode 1, you can see you have the 1 input, and then you have the 4 outputs, and then the last output you can see goes into a different unit's input, and then you have another 5 outputs. So you can have 9 total with just 2 units.
Right,
and
so
then,
1 all the way to 9. So 1 unit, you can feed the signal into 1 port at the very extreme right here, and then have it repeated 9 times. Right, go ahead.
Right, and then in mode 2, you can have 2 different signals. In mode 2, you have,
yeah, and 2.
right, and then you have essentially the same thing. You have except you're using two of the transmit ports, one that's containing signal 1 and one that's containing signal 2, feed it into the two input ports of the second one, where they are then repeated again. So you can get extra ports that way as well.
Right. And you can continue this many times and without any degradation in the signal, and create a large number of duplicated signals. This is a little bit busy, but if you follow it very carefully with the color-coded designations there, you should be able to figure it out. Okay. Zach?
So these are the rates we cover. So for Sonnet, we can go from OC3 up to OC48. And for Ethernet, we can do 100 megabits all the way up to 2.5 gig.
Right.
And we can do this through one SFP. It can do either Sonnet or Ethernet up to 2.5 gig. The only exception being 100 megabits per second. That's a separate SFP.
Right. And that's pretty convenient. So you can handle both Sonnet repetition as well as Ethernet repetition. And that makes it very flexible. You don't need to buy separate repeaters and so on. So we've accommodated that flexibility there. So it saves you money as well as time and SFPs. Zach, you want to go through this list of features that you can do?
Right. So this is just another general overview. The optical tap repeater can accept up to 6 standard SFPs ranging from rates of OC3 to OC48 or 100 meg to 2.5 gigs. They can be electrical or optical, single mode or multimode. And again, it has those two modes, with one of them being a pass-through with 5 identical outputs, or mode 2 where you get 2 inputs to 2 identical outputs. You can cascade 2 or more for greater repetition. You can convert single mode to multimode or multimode to single mode with optical SFPs. And then you can also convert optical to electrical or electrical to optical, depending on your SFPs. And all of this can be done with error and jitter-free repetition, because these are active units. They are not passive, so there's no loss.
Right. And I just wanted to emphasize a couple of points here. One, and that is this conversion capability. So if you recall, SFPs, because of the standardization bodies, there's something called the MSA standard for SFPs. So that allows the SFP to handle both electrical signals as well as optical signals. And the only difference is, as long as the electrical interface at the end of the SFP inside the circuit board is MSA, the actual interface can be either copper or optical. So and it can either be single mode or multi-mode. So what happens is all of the complexity of interfacing, whether it's an electrical signal and the data rate, or whether it's an optical signal, single mode or multi-mode, and what the data rate is, whether it's 100 megabits or 2.5, all of those are all addressed in the SFP itself. So the actual repeater that we have designed is compatible with MSA. So there, the signals are all the same. And so we can repeat or repeat those in any of the modes that we described. And then as they are fed back to the SFP, they again take on the characteristic of the SFP. So for very little cost, you can use the repeater as a converting device. So you don't have to have a slew of SFPs for single mode and multi-mode for one rate or another rate for electrical and optical. You can just use the repeater to deal with the system that you have and the other system that you're trying to become compatible with. So that's actually a very handy capability in the lab where you're having to deal with a lot of different interfaces and fiber types. Okay, let's go to the next slide. This is the one. Okay. So if you were paying attention, you noticed that we had two different optical repeaters. One was for 100 megabits up to 2.5 gigabits, and the other one was for 100 megabits all the way up to 10 gigabits. And the reason we did that is because of the actual circuitry that we have to use to try to make it cost effective for the whole range. We did have to divide this up. So Zach, go ahead, give us the details on this.
Okay, so yes, this is our 10 gig optical tap repeater, and you can see it has 4 ports instead of 6. And one big difference is the through ports are the center ports, and then the repeater ports, the transmit ports, are on the sides. So if we go to the next slide.
Right, and before we do that, so this is our emulation system. Our Packet Expert, Sonnet Expert is the device that is shown here. And this device can do anything from 10 megabits to 10 gigabits Ethernet, as well as it can do almost all of the conventional Sonnet rates, which goes from OC3, that's 155 megabits, to OC192, also called STM64 or STM1, STM1 to STM64, and OC3 to OC192. So this Packet Expert is a very let's just say exhaustive device. It can do, with it you can interface to both Sonnet and Ethernet at all those rates that I mentioned. It can also, with the right accompanying software, you can do Sonnet as well as packet analysis. You can dig deep into the packets and do protocol analysis. You can dig deep into the Sonnet and do the TDM analysis. And so this is a typical emulation system, a very, although it's not that expensive, but if you wanted to do a lot of channels, you can theoretically do thousands of channels here. But if you wanted to replicate that, this is how you would do it. You would run this Packet Expert, be emulating a signal between systems A and B that would go into these 2 ports, and then you would duplicate those signals through this repeater. This repeater is 1/20th the cost of this system. So for 1/20th of the cost, you are now duplicating the same emulation capability, and you are able to test a high capacity switch or gateway or transmission system for very little cost. So that was the whole idea behind using these repeaters, or if you're monitoring the other application that we were talking about. Okay, so let's go to the next slide. And these are the rates. Go ahead, Seth.
So these are the rates covered by this repeater. As you can see, it contains all the rates of the previous one, except now it can go up to OC192 in the Sonnet world, which is 9.953 gigabits per second, and then also 10 gig Ethernet.
Right. So you can go from 100 megabits to 10 gigabits. The terminology that's used in this business is always, keeps you alert. Okay, they use, first of all, in the Sonnet SDH world, right? There's Sonnet and SDH. They're actually the same, but they use different terminologies. One is European, one is American. Then they use megabits and gigabits, and of course GigE. These are all the terminology. So all of these, this one box can handle all of these rates, which makes it very flexible and convenient to use. Zach.
Okay, and here's what it would look like in the 1U rack unit. Again, you can just condense all of your repeaters into one box and put it on a rack, and then you can cascade them if that's what you want to do. And
okay. It provides a convenient way of installing and securing your units, rather than the tabletop versions, which we saw at the beginning, which could conceivably run away.
And here's what it would look like cascaded. So you have the east to west, A and B, and they come out, they're repeated from the outer ports, which are then fed into another repeater, input ports, which are then repeated again. So you get that same cascading that you saw with the other repeater right here. Right.
So the emulation system is here. A and B is being used to emulate traffic, anything, right? When you talk about emulation, you can be emulating a lot of different kinds of traffic, protocols, interfaces, data rates, and so on. You could be talking about hundreds of calls to thousands, hundreds of sessions to thousands of sessions, but this repeater system gives you a very inexpensive way of repeating that traffic and loading a system or monitoring that same system, and makes for a very cost-effective solution for bigger systems. Zach, go ahead.
And just an overview of the features. It can accept 4 standard SFPs or SFP Plus from OC3 to OC192 data rates, or from 1 GigE up to 10 GigE. And then again, also we do that 100 megabits Ethernet as well. And these can be single or multi-mode, or a mixture of each. Again, we talked about converting single to multi-mode. We do not support 10 gig electrical SFPs. They use a lot of current, so we are limited to 2.5 gig electrical SFPs with this unit, and then anything below that. But 10 gig optical is still okay. And again, we can cascade 2 or more for that duplication of the signals with no errors or jitter. Again, just like the previous optical tap repeater.
Okay, super. And so I wanted to mention again, the error-free and jitter-free is very important, because whenever you repeat a signal, it's important that the repeated signal, because remember, you have to recover the actual bits. Each bit is recovered and retransmitted. So that error-free and jitter-free operation is an important thing. So, okay. All right, so now we're going to get to T1 and E1. About 25 years ago, we came out with T1, E1 single and dual multi-port repeaters. And we have the pleasure today of having Steve Wasilko give this presentation, because he's the designer of these as well as the optical ones. Steve, take over.
Yeah, I'll be presenting on the single and multi-port repeaters. So next slide, please. This shows the suite of the single and the multi-port repeaters. The single only do one side, where the dual, we're talking about repeating the east and west. So we have a single Bantam version, which provides 10 identical outputs from a single T1 E1 input. We also have which is the top left. The bottom left is a single RJ45 version, providing 12 identical outputs from a single T1 input. Then on the far right there, you have the Bantam and the RJ45 versions, which are dual versions, which provide 4 outputs for each of the 2 inputs.
Okay. Believe it or not, these Bantam variety is still used quite often, because people are not necessarily changing out their circuit configurations as quickly as what you might think. So RJ45 is sort of what's in vogue now, but a lot of legacy stuff still has Bantam, and even if some of you guys out there might even know about the 310 plug. Okay. Go ahead, Steve.
So as one of the features, it generates identical T1 E1 outputs for each T1 input, thus increasing the range of transmission of T1 and E1 signals. Output signals are regenerated versions of the input signal. We preserve the strength of the signal and extend the distance over which the signal can be transmitted. Useful in lab environments for load testing and signal duplication purposes. We test and load multiple T1 interfaces simultaneously. We broadcast applications, generate traffic generation, and simulation. They're also used in the same MTOP racks for T1 and for 1U and 2U rack enclosures with T1 and E1 multiple repeaters can be stacked to provide a high density form factor. The input features, we support the termination and monitor at 120 ohms for E1 and 100 ohms for T1. In the bridged application, we can bridge off a signal and provide a 1K input impedance, so we can do all three with the switch on the back panel there. The single multiport repeater contains 10 or 12 identical outputs, like as mentioned before, and then T1 input signals generated provide 10 or 12 outputs.
Okay.
Again, going over here, the dual repeater will provide two independent sections of logic that repeat and multiply the T1 input, T1 E1 signals. Each input is replicated 4 times at the output. For each section, the input termination is 100 ohms for T1, 120 for E1, and we provide a balanced or RJ45 control through a front panel switch. The output sections are 4 outputs, and 2 outputs are 100 ohms and 120 ohms for E1 balance for Bantam or RJ45. The output one section can be fed identical input to the other second section, thereby providing an identical output consisting of 7 Bantam or RJ45 outputs. So what they're trying to say here is that you can cascade these just like you did the other optical repeaters and the other electrical repeaters. You can cascade these to have more than one output if you needed 7 outputs out of a single device.
Right, and right here on the front panel, we have these 3 different modes. As you all know, in the T1 E1 world, a T1 signal can appear. You can either terminate it. It could be a signal that has high impedance signal, which means it's a bridge type of signal. So you have to, it's an attenuated version. So you have to be able to dig out that low level signal, or it can be a monitor level signal, which is again, a low level signal off of a DSX patch panel. And some convenient LEDs are provided for diagnostic purposes. Steve?
Yeah, showing here, just like the optical repeaters, we're able to put these in multiple racks and do cascading. So we're able to provide a high density T1E1 multiple repeater form factor solution, which are used to generate multiple identical T1 outputs for each T1 E1 input, thus increasing the range and transmission of T1 E1 signals. The chassis comprises of a single or dual multiport repeater with a stacked USB, greatly reduces the license cost per unit.
Okay. All right. That was a quick presentation, a simple one, but it's very practical. Sanjeev, do you want to take over?
Yes, Vijay. Thank you. Anyone of you have any questions, you can just ask us now. Yeah, we have a couple of questions. One is, are the outputs of these repeaters guaranteed to be error-free?
Okay, so I think I mentioned earlier that all the outputs are jitter-free and error-free. I mean, to a technical, to a very low level. There's extremely low level of jitter transmission, and they are error-free. I think Zach has tested these repeaters over weekends and for many days. Zach, maybe you can relay your test results associated with. I think you've tested these things for what, days on end, right?
Right. So we saw on that one slide we had the packet expert. I've ran these through 1 gig Ethernet over weekends, 2.5 gig Ethernet, and also with the 10 gig. And that is with all ports loaded up, and never had any issues over the several days they were running. And that was with bit error rate tests, so counting each bit, there were no issues.
Right. So that means that there were 0-bit errors over many days. So that means that it was basically error-free. And if there, there was not any jitter that would cause any errors. So otherwise, you'd have to look at to identify the jitter. You have to look at it on a high-speed scope, and we know that that would cause errors if there was any jitter accumulation. Okay, so Sanjeev, I think that answers that question.
Yeah, thank you, Vijay. Next question is, do we supply the SFPs with these repeaters?
Okay, so we supply the multi-rate SFPs. You have to select whether you want the single mode or multi-mode, and we will provide the optical repeater with the single mode or the multi-mode, and there will be multi-rate so that they would be able to address all of the rates that we mentioned. For example, if you ordered this repeater, then they would work from 1 gigabit to 2.5 gigabits, and the sonnet rates of OC3 to OC192. The only rate that would not be covered, you have to order that specially, is the 100 megabit optical. That's the only one that would not be covered by the SFPs that we provide. If you needed that, then we would provide you that specially. And if you order the 10 gig optical repeater, we again provide you the multi-rate SFPs for those. But you have to specify whether you want single mode or multi-mode, because they are a separate batch. Okay?
Thank you, Vijay. I think that's all we have. All the questions are answered.
Okay, super. We did this one kind of fast. And if there's any questions about this, please feel free to ask us. These are all off-the-shelf units. We'd be happy to entertain any questions or orders for these repeaters, and they're very handy for the lab environment, and we use them all the time in our lab. Okay, great. Thanks, Sanjeev. Thanks, Zach. Thanks, Steve. Thank you all.